So the topic today is building CI/CD for non-deterministic AI agents at scale. And really, we're going to talk more about CI than CD. I'm going to touch a little bit on CD at the end. But the challenge here is for anyone building AI agents, how do you really like test and deploy a system that doesn't behave the same twice? And if you think about the agents that use maybe Cloud Code or GitHub Copilot or coding agents, or if you're using agents to do DevOps tasks or anything dedicated for that, like how do you go about, if you're a company developing one of these, how do you go about developing and measuring that when you're building upon of these like fundamental building blocks, like large language models that are fundamentally unreliable? You give the same input twice, you get different output two times back. So a little bit about me and my own background with this. So I'm the CEO at Robusta Dev. We build AI agents for on-call, and that's based on an open source project called HolmesGPT that we maintain along with Microsoft. HolmesGPT is on the path to become a CNCF sandbox project. We've already submitted it with Microsoft, and essentially it does it's an AI agent that does AI analysis of incidents and problems and troubleshooting and alerts. So like as an example here, one of my teammates is tagging it here in Slack saying like, okay, look at some problem in the Kubernetes cluster, check the logs, check the pods, see if you can figure out why this problem is occurring. And then the agent goes off, gathers up all the data. Of course, it's read-only, gathers up a whole bunch of data, analyzes that, gathers up more data. At the end of the day, comes back and gives you a response so that you can respond to an alert or an incident faster and hopefully go back to sleep at 3 a.m. Now, the goal and like of today's talk and like the big challenge we faced along with everyone else in the space is, well, how do you go about measuring that and building like reliable software? Does everything that we've learned in the past 30, 40 years of building software suddenly go out the window and become irrelevant because like, okay, no, there's no more CI/CD, there's no more unit testing, there's no more regression testing, like none of this is and none of this is reliable, none of this is relevant. So does all that suddenly go out the window, or is there some like reasonable and good way to adapt this that makes sense? So I'm going to speak today from our experience. And for us, this is like really important because like we're building an AI agent and we can't ship something to our customers, to our partners, upstream customers, meaning like customers of Azure AKS to our enterprise customers, the open source community. We can't ship things to people and then say like, okay, well, like it worked on my machine. Now you're trying on yours and it doesn't work. So you have to have a way to take, when you're developing an AI agent, you have to have a way to take something that's fundamentally unreliable and still make that engineering and not voodoo. So that's what the talk today is about. And I'll give you a few examples of this, but like you could do a change or add a new feature or do something that seems like an incredible idea and it's going to improve your agent's accuracy and it's going to make it do all these things that are better. I'll give some examples of this in just a moment. And it makes results go into the trash. So it becomes really important to be able to like do almost the equivalent of unit testing on AI agents, but walk through what that actually looks like. So that's kind of the goal and the motivation. And I see there's one question in the chat. Is that what you're using for Azure SRE? So no, there's two different Azure agents. There's the Azure AKS agent. This is what powers the Azure AKS agent. That is newer now in preview. And it's not related to the Azure SRE, which is a different team. That's not based on open source as far as I know. But again, I only represent Robusta. I don't represent Azure here. I'm just mentioning them because they also use this open source. And we've had fantastic partnership with them. Okay, so let me give you an example of adding a new feature to the AI agent that we all thought was a fantastic idea, and then suddenly, like you add a feature, and it's like playing whack-a-mole. Suddenly, like problems start popping up all over the place that you didn't expect. So one of the ideas that we had here is we said, okay, like we have an AI agent. It has access to your Kubernetes cluster, it has access to your observability data. I can like run some stuff. I can gather data. I can read your alerts. You can go off and fetch information. But there's some knowledge sometimes that you only have inside your own company, right? We all have these runbooks, or we don't have the runbooks, but like we have runbooks, we have Confluence pages. Maybe we have previous discussions on Slack where we spoke about a similar problem in the past. Could we let the agent tap those discussions of previous incidents and then give better results? So on the surface, the answer seems yes. And we all thought that was a great idea. So we went off and we implemented it. And we added a tool so that the AI agent can like fetch runbooks and has a curated catalog. So there's like community defined runbooks. It's like the Azure team contributed a runbook on how to troubleshoot DNS issues in Azure. Okay, that worked really great. And then users define their own runbooks or hook it up to their existing runbooks for how to troubleshoot problems in their environment. And here was an example runbook we gave it. So like, okay, here's an example in troubleshooting high latency on AWS. And like, here are the steps to reduce some example commands. Pay attention here. We're giving a specific command, like to get these specific metrics and stuff. And then afterwards, you have some examples of like how to interpret the results. And we saw two really interesting things. One, when we do this at the more powerful models, everything was fine. Everything was fantastic. You put this up to Sonnet, it just worked. No issues. But when we put this on the weaker models, by weaker models, I mean GPT-4o, like a model that was almost that was really state of the art until 2 weeks ago. I could consider almost state of the art until a few weeks ago. Even stuff like GPT 4.1, when you put them up to this, and you give them access to read these runbooks, then we started suddenly seeing these really weird failures. The AI agent would like get a question around how to troubleshoot AWS Lambda, and it would go off and it would read the runbook, and then it would give complete hallucinations, which never occurred before. So here's an example. And I'm looking here through trace data. So I'm not going to talk about tracing today and how you like add traces for AI agents. It's kind of the focus today is really more on evals and how you do the testing. And that's on tracing and the observability side. But just so that we can all like discuss this and then kind of look at examples like this, this is a trace of what the agent is doing under the hood. So here's the input that user gave. My AWS Lambda function, payment processor in US East has high latency issues, investigate why. And then here's the output from the agent. And it says like, okay, I found the runbook, used troubleshoot, I performed these steps, I query performance metrics, I check function logs, I did this, the function duration was higher than expected. It's giving what seems like a great analysis. The only problem is that it's a complete hallucination. So if you look at what it actually did, then the agent like started running, called GPT-4, it read the runbook, and then finished the investigation. And we saw that with models like Sonnet, this of course didn't happen, but with models like GPT-4o, when it read a runbook, like this runbook, then it got confused and it thought it had executed the runbook. So when it saw example commands like this, we saw that the agent was getting confused and not thinking, oh, I should run AWS CloudWatch get metrics, and I should, of course, replace like these metric names and this stuff with my own examples. It was getting confused and instead thinking, I ran these commands, here are the results, and then, okay, I'm done. There's nothing to do. So this is an example of kind of that game of whack-a-mole. You add a new feature, you do some testing, like it seems to work well in your scenarios, but then like suddenly in production it starts doing weird things. Now, taking this back to like traditional software engineering and platform engineering, right? Like, well, we want to do unit tests, we want to have regression tests, we want to have end-to-end tests, we want to like kind of test for this sort of thing. How do you catch this sort of thing in a testing phase and not discover it from your customers? So this was something that, of course, we call in the testing phase. And the answer and the way that you go about doing this is evals. And we'll speak about that in just one more moment. I want to give one more example first. Another challenge that comes up all the time when you're developing AI agents and trying to make them reliable is what approach is best? And I'll give you an example. So here's a question like, okay, why is payment service down? And this is what a user would ask. And then here's the answer that older versions of our agent, version 1 of the agent would give. It would say, okay, like looks at the payment service, reads the logs. It sees that the payment service can't connect to this Postgres database. There are connection errors. And it comes back and says, okay, it can't connect to the Postgres database. There are connection errors. It's not a bad result, right? There's always correct. The result is somewhat useful, but like, what are we paying? What are we paying for all those tokens for? Can't you do a little bit more than that? Like, well, it really begs the question, like, why can't this connect to the Postgres database? So like a good answer would be like, okay, I can't connect to the Postgres database because there's this network policy and it's blocking the payment service from connecting to the DB, and that's why connections fail, and here's how you can go and fix it, right? So we had our AI agent, OpenGPT, the open source agent, was consistently giving these answers and not these answers. And we wanted to like take the AI agent and kind of make it give these answers. So now in traditional software engineering, right? You might do like test-driven development. So you might write a test and try and make the test pass. And it's kind of what evals are like. And we had here two competing hypotheses, like two competing ideas for how we should get the agent to always give these good answers. One of them is what we call hypothesis generation, which meant that the agent up front would like take a question like this and then would come up with a whole list of hypotheses. And then we would force the agent to go through one at a time and check each of those hypotheses. A lot of the commercial software on the market, actually, like the commercial agents, that we compete with actually do that sort of thing. And then the alternative idea was a more simplistic approach, which is just let's give the agent a to-do list, like how Claude Code works, for example, and let the agent track its own to-do list. And you don't need to explicitly structure this as hypothesis tracking. So I'm going to now speak about evals and how evals suddenly make this and the previous example really, really easy to do. So what are evals? Evals are like unit tests for agents, and you often write the evals before you actually write the feature in the agent. So they're almost like test-driven development here. And the core idea is that you define scenarios you want to test the agent on. You run those scenarios, ideally before you've even implemented the feature that would make them pass. So you see the scenarios reliably fail. And if the scenarios somehow pass, then that's something interesting worth looking at. And you don't go off and implement that feature. And then you define a bunch of these scenarios, and then you score the results automatically using another large language model. That's often called the judge. And then so imagine you have like 100 of these scenarios, you develop a feature, you run all your 100 scenarios, you get back results really fast because like each scenario is automatically graded. So you're running the agent on a scenario, and then there's another large language model that's judging whether the AI passed the scenario or not. And now you have a way of saying, like, am I improving performance or making performance worse? And I'll make this all concrete in a moment and show you examples. And then you can take this, now you can integrate this into CI/CD, like as a blocking check that's part of your CI process, for example. To merge, you have to pass evals as an example. So they'll be on the workflows around this. One way you can use this that we do is we have a set of evals that we call regression evals. So these are scenarios that we expect the agent to reliably work on every single time. And we run those on every single commit, on every single pull request. And then if someone makes a change and suddenly the agent is failing on one of those evals, then you know that you've introduced a regression. So this is really like having unit tests and doing regression testing with that in traditional software engineering. The other side of evals that also proved to be really useful is to have hard evals, to explicitly have evals that your agent is not capable of solving today, because those are then your target for improvement. And then that's a KPI. When you go and develop a new feature, you now want to see some of those evals turn green. The other ways that you can use evals, this is not necessarily part of like CI/CD in the software development lifecycle inline, but you can use them to make decisions around like accuracy versus latency versus cost. For example, do we want to roll out Sonnet or Opus to everyone? How much would that cost us? What would be the increase in latency if we use Sonnet versus using kind of a weaker model like GPT 4.1? Or should we use GPT-5 or should we use Sonnet? They both seem to be strong models. Which one is actually better on these use cases? So when you have evals, you can run the evals on each set of models and then get a really, really clear-cut answer. Okay, so let me show you what this actually looks like. So to make this real concrete. So I'm going to show you a definition of an eval, and then we'll run it together, and I'll stop for questions as well. But if you have questions, write them in the chat in the meantime. So let me blow up my screen a little bit. Here is an example of an eval. This is essentially a test for our agent. So our agent is supposed to be able to troubleshoot like problems in cloud-native environments, and here is one such problem. So what we do is the user is asking, okay, what is the issue with Redis? And the expected answer is, okay, like Redis standard PVC can't bind to the storage class because this standard v2 PVC storage class doesn't exist. So this is like a very Kubernetes specific scenario. But what we're really checking here is like chain of causation. That agent can like look at Redis, understand that Redis is unhealthy, see that Redis can't bind the PVC, then look at the PVC, see that the PVC can't be bound because the storage class doesn't exist. Like checking the agent's ability to go down the whole chain of cause and effect and not just return the first answer, which is like Redis is pending. Okay. And this was originally tagged as hard because this was an eval at the time we weren't passing. And then the way that we run these evals is we want to test the agent. This is really, really important. We want to test the agent in real life. When you think about how you would test this, then you essentially want to like test the agent on a scenario where you have like an issue with Redis and there's a PVC that can't bind. You want to test that the agent does well in this scenario. There are two ways you can think about doing this. One way is with mock data. So you could say like, okay, the agent is going to run like kubectl get, it's going to get fetch this other information. We'll get mock data for each of those. That turns out to be a really, really bad idea. And then the other way that you can do this is you don't mess around with mock data. You just say, okay, like I'm going to create this scenario in a test cluster, and I'm going to throw the agent at it, and it will run this all like in the live, realistic environment, and then we'll see how the agent does. I'm going to speak to you. I'm going to show you what this works, what this actually looks like. We'll walk through this, we'll run it. And then I'll speak more later on why it's a bad idea to use mock data for this sort of thing. So just to finish the part in the scenario. So, okay, so before this eval runs, we're going to set up the environment. So we're going to create a namespace. We're going to apply YAML. If I open up the YAML there, it's a YAML from GitHub. If I open this up, then you can see there's like a Redis here that's trying to find PVC storage class that doesn't exist and so on. So let me go back here. So essentially it's going to set up this environment, create these resources in my Kubernetes cluster. Then we're going to ask the agent, what is the issue with Redis? The agent is going to give us some answer. We expect that answer to have these. What do you mean? What do I mean? We expect the answer to like satisfy these three criteria. I mean that we're going to get back the answer from the agent, and then we're going to feed this automatically into another large language model that is going to take the answer and it's going to compare it with this. It's going to make sure that every single one of these is satisfied in the answer. And then the test finishes, so we tear it down. So let me just go and run that. And I'm running this locally. In this case, I'm running it on Sonnet. And you can see the first thing that it's doing is it's setting up the test environment. So we're like deploying manifest to the cluster. Then now it's starting up the AI agent. So it's going to actually run this on this sort of scenario. While this runs, I'm just going to scroll up, show you. I ran this right before we jumped on the call, just that we don't need to wait. So okay, it runs this. You see that the agent is like coming up with an investigation plan. The output here is ugly just because it's part of the test framework. But you can see the agent is coming up with an investigation plan. I'm going to like first find Redis resources in the cluster. I'm going to check the Redis pod health. I'm going to examine the Redis logs, check Redis events, and so on. Works through that whole investigation plan. At the end, it comes back. It gives an answer. And then this eval passed. And I'll show that to you over here. So we're grading the eval. So here's the expected answer. Here was the real answer it gave. I'll open that up a second full screen so you can see that more easily. This passed the test criteria. So this eval passed. And when we run these in the real world, and we often don't run these just one time, we'll run these like dozens or hundreds of times because these are still statistical, right? We're testing an LLM that's non-deterministic. So we want to see that this passes 100% of the time, or that if this is a really hard scenario that we're passing now 80, 90% of the time. And then we can measure the cost on that. We can measure everything that went into this run. And essentially, this is the equivalent of unit tests for the AI agent era, right? We have here essentially a self-contained test, and we're able to use this now to verify that there are no regressions in the code. And using something equivalent to test-driven development, we're able to actually write the evals, then develop the agent, and now see that the agent actually passes on those evals. So let me open up just the results to show you an example of this. We're using here a system called Braintrust, other commercial provider, but we pay them. I'm not affiliated with them. That does evals. A fantastic open source solution here is just Prompt Foo. So Prompt Foo, if you're looking for a good open source solution, Prompt Foo is a fantastic open source solution. We moved away from Prompt Foo because we wanted to do evals as code instead of evals as YAML. So it's kind of like moving from like Kubernetes manifest to Terraform. So there's, depending on the complexity of what you're doing, then you might want different solutions. But Prompt Foo is a really, really good open source solution to get started with.
We've just got one question that's just come in, which I think was probably a good time to grab it now. What kind of criteria do you use, and how accurate is LLM as judge in the evals for your use cases?
Okay, fantastic. The LLM as judge is pretty reliable if you use a good model. So you have to use a model that is just as smart as the model you're testing, if not smarter. So you don't want to use a weaker model. You might think I can use a weaker model to judge it, but that turns out to be wrong because then it loses all sorts of nuances. And if you want to see the prompt, I'll show you. So I'll walk you through the result here, and then I'll also answer more on like the type of criteria we use and what's good criteria versus bad criteria in our experience. So here's the question: what is the issue with Redis? Like here's the answer on why it can't start. It's saying, okay, they're using this non-existent storage class, and available storage classes are such and such, or the affected pods and so on. And then I'm going to go over here to the correctness. So this is the judge. So it's getting prompted, like you're evaluating the correctness of output given by an LLM. You have to return a score. This score is pass fail. So it's not like 0 to 5. The score is always pass fail. We'll speak about that more. And in order to pass, then like each of these expected elements must be present in the output. Here's the output. And then we're getting back here the result, which like has the reasons and the thinking on what it did and the choice it made. So like it shows over here was the input. Here's the output. It's going and evaluating, and that's explaining why it made that choice. So if the judge gets something wrong or you're seeing behavior you don't expect, then you can go and you can troubleshoot this. Okay, I want to speak a little bit about the criteria, and then Dan, you're telling me if I've answered your question or if you have a further question on that. Here are 3 mistakes that we made with evals a lot early on, and that we don't do anymore. But that are mistakes that we made very early on that bit us a very large number of times and were painful. The first was accuracy scores. So if you look at a lot of eval frameworks and stuff, like a lot of the best practices, so to speak, will like point you in the direction of setting up like evals, and then like you have these scores like safety, you have these scores like accuracy scored between 0 to 10, and you have like these complex scoring, and then like a lot of the traditional way people, a lot of the way people, not traditional, but a lot of the way people recommend to work on something like this is not to judge this as pass fail, but to give a whole bunch of scores, like the helpfulness of this answer is such and such. The accuracy of this is such and such. For our use cases, we found that to be really not useful because we would get back like a whole bunch of scores. You get back like, okay, accuracy 3, and then like helpfulness 4 out of 5. And it turned out to be a lot dependent really on the judge then. And there wasn't a clear criteria on what it actually meant. And when we switched to these binary pass-fail evals, then suddenly everything became easy. So we switched to pass-fail evals, and then like if I'm looking at going back to the definition, like what's the issue with res? Either the expected answer says 1, 2, and 3, includes those 3 things, doesn't have to be those exact words, but it must include those 3 criteria. Or it doesn't include all 3. That might include 2 out of 3. It doesn't matter, but it fails. So when we do use all of our evals or pass-fail criteria, and then it makes it super easy to debug because you run something, you know, like, okay, it's like a unit test. If you think of a unit test, like how useful would a unit test be if your unit test came back and like you ran PyTest or whatever, and unit test run the CI/CD, and then instead of giving you pass fail and like having the CI/CD job fail, you just got back a number 80. It'd be hard to use an interpreter. So we found that pass fail evals are several orders of magnitude more useful and actionable than evals that are just scored with like usefulness or helpfulness and so on. But for us, we do have an advantage here, which is that for every answer our agent gives, it's either clearly correct or clearly not correct. So like if I go into ChatGPT and I ask for a recipe, for example, there is no clear like pass-fail criteria on did ChatGPT give me a good answer. Whereas on our evals, there's always a very clear pass-fail criteria on is the answer good or is the answer bad. I'm going to walk through the 2 other items here, and then I'll address all the questions. So the other mistake we made was we tried to mock the environment. So what we would do, to give you an example, we still have some of the old mocks around, is we would say, okay, like the agent in this case, it's going to look at Redis, and when it investigates, we know it's going to run kubectl describe. So we'll like give it mock data on kubectl describe. So if it calls kubectl describe, and then it tries to look up a persistent volume, and then feed it back this data. And this looked like a really promising approach because it meant we could run these much faster. We could run them in CI/CD. We didn't have to have a real cluster set up to run any of these. We could like mock all the data. You'd run the agent. It would use all this mock data we had gathered in advance, and then it would give an answer. And you don't need to have a live cluster. You don't need to worry about any of that. You don't need to worry about any of the messiness. This turned out to be a terrible approach because the agent would end up taking extremely different paths to investigate, yet still reach the right answer. So what would happen is we'd test the agent, we would run an eval, like we would run this eval on what's the issue with Redis. And then instead of running kubectl describe, we're running kubectl get. Instead of running kubectl get, it would run some other command. And it would do things that were functionally equivalent, that all work, that are all supported in the agent, but that took very different investigation paths. So then we would add more mocks to cover those investigation paths. But then you end up with mocks like on inconsistent data. Like they're like, let's say you have a deployment running in your cluster on one day and it has a pod with a certain name, and then the pod dies and a different pod comes around. You're adding new mock data, you end up with inconsistent mock data. You end up constantly fighting to add new mock data, new mock coverage. And what broke us was we had been doing a lot of work on GPT-4o, and then we started testing on Sonnet. And suddenly on the first eval we ran on Sonnet, it said I'm missing 100 mocks. And we said, like, screw it. We're not doing mocks anymore. We're just going to test it in the real world on real environments. And that has worked really, really well for us. I'll show that to you in CI/CD in a moment. And then the other problem that we encountered a lot was cheating. And what I mean by that is sometimes the agent would give results that were just too good to be true. And we've seen this like when we've seen this with our own agent, we've seen this when we do comparisons. You like run the agent and it comes back like 15 seconds later and it tells you exactly like what you were testing. That gives you the perfect answer. And you go, wait a minute, how did it reach that answer? And then like you look at it and you say like, okay, like we deployed like some deployment to the cluster, we deployed some YAML to the cluster, and there's like a manifest there, and there's some source code. And inside the source code, there's like a comment in there saying like, in this eval test such and such, that's right, let's do such and such, so that like let's set this up this way so that we'll send this data, and then the agent will be able to pick up that data. And then the agent we're testing just somehow manages to like see the source code and see the comment, and then instead of testing any of the things it's supposed to test, it just knows what the answer is and it cheats and it writes you back the answer. And it doesn't actually like do the test at all. Or we saw this when we had head-to-head comparisons against Claude Code once. And then Claude Code like came back after like in a fraction of the time and he gave us like a fantastic answer. We're like, wait a minute, how's Claude Code doing that? And it turned out it was just reading the files for the eval definitions on disk. So you have to be really, really careful to make sure that your evals are actually testing what you think they're testing. And what helps is like to take a case where the eval is passing, like, okay, here's an eval, this is passing, but then to go through, look at the tool calls, look at exactly what the agent did, and to make sure that it actually is reaching the answer for the reasons you think it's reaching the answer. So you do that once or twice when you're adding new evals. Of course, afterwards, once it's up and running, you just continue to run it. You're not checking every single time. But these were the three big issues that we encountered again and again. When we tried to do like criteria for the evals that was not pass fail, but was kind of judged on a scale. For us, it turned out to be very, very hard to interpret and not at all actionable. When we tried to mock the environment so the agent didn't have to run on a live Kubernetes cluster, and then when we just weren't careful enough and the agent was getting the right answer, but it was getting the right answer in a way that was not all representative of what a user would encounter in production. It was just like reading the definition of the eval itself or cheating in some other way. So it's also important to like to monitor for that and then make sure you're limiting the agent's ability to actually cheat. So it has to solve it like the real proper way. Okay, I see there are some questions. So first question, do you or anyone you know within the market offer white label agent dev services? I'm gonna again recommend someone. This isn't official. There's no official affiliation, but so you find it. But yeah, okay, perfect. So there's a guy, Hamel Hussein. We sent two of our employees to a course that he runs on. I'm blanking on the name of the platform, but he runs a course online on evals, and I know he's done a ton of consulting. A lot of what we did initially was based on the stuff that he wrote on his blog about how they do evals, and like creating an LLM as judge that drives business results. So a lot of his writing was a big inspiration on the work that we did ourselves. It was incredibly useful in building for us like a really useful eval framework that gave fantastic results and actually helped us make decisions and still helps us, really drives what we do on a day-to-day basis and how we develop the agent. I have no affiliation with him at all, other than the fact that we paid for one of his courses. But I do think he does consulting and that they do work around this. So this isn't an official recommendation, but it's someone who I know of whose blog posts at least have been very useful for us. So Rod, I hope that helps. Okay, back to the question now from Padovala. I hope I'm pronouncing your last name correct. And you said, if I understand correctly, does the agent produce different results every time you run the same test? That's why it's called non-deterministic. and you're looking for certain elements in output to calculate accuracy and passing the test. Absolutely. So let me show what this looks like in CI/CD. So here's an example on our open source project of a pull request. And the goal of this pull request was to like improve the ability. We have a connection with Datadog. So the goal of this pull request was that when we queried data from Datadog, one of the failure modes that we saw was sometimes like the agent would look at the cluster, you ask a question about a pod, it would look at the cluster, it would say that pod doesn't exist anymore, and then it would stop. And what we wanted it to do is we wanted an agent to say like, okay, the pod doesn't exist anymore, but I have access to Datadog, and I can query the right data from Datadog even though the pod isn't around anymore. So like this was a PR where we made a ton of improvements so that the agent started actually relying on Datadog data when it was available and didn't stop investigating early and say, oh, the pod is no longer around in the cluster. So here's an example of an eval for like that. And then on this, we ran 290, we ran 315 evals in total, 15 regression evals, 2 hard evals, 2 evals specific to logging, and then 245 runs. This is with the repeats, so we run the same eval multiple times, but 245 evals here related to like tapping the data from Datadog and questions that it needs to answer. And then on every PR like this, so this was an extensive run that we did where we like ran this just from the CLI with a very large number of iterations, and then seeing that every single time it produces a satisfactory result. So Padavala, going back to your question, it does produce different results. If I went into each of these like runs, if I saw the same question asked multiple times, we would get back different answers every single time. But as long as they still had certain elements in the output, that would still pass. And the only way we can do that is by having like another LM actually judge that. So here's like an example of output. If I go back over here, like to the CLI, you can see here we're getting output like on how many passed, how many failed, details on that. We can drill down to tracing data, how much it costs to do the whole run, and so on. We can get all that data here in the CLI. And then we also, on part of CI/CD, I promised CI/CD in the title of this talk, and I meant it. As part of CI/CD, we go and we run these evals on every single pull request and every single commit. So here's an example of the results on the evals. Some of the tests we skip in CI/CD, and then other ones still have, this was a set failure. So the eval itself is fine. Like we failed in setting up something in the Kubernetes cluster, but the eval itself never ran. So this is an example of like how you view the results in CI/CD, and then of course you could click to drill down to results. If anyone is curious, this repository is open source. Everything here I'm speaking about today, I think every single thing I'm thinking about and showing, probably every single thing. Don't catch me on that, but I think every single thing I'm thinking and showing, I'm discussing, sorry, and showing is open source. So you could, if anyone is curious, like you go into the GitHub Actions and see how we have that set up. Okay, so Padaval, I hope that answers the question. And for Gordon, for Daniel, for Rod, and for Padavala, if you have a follow-up question on that, or if I didn't answer, just write in the chat. And I see that Masashi has a question as well. You wrote, the eval as the agent is the unit test for the agent. How expensive would it be? So it's a good question. So GPT-4o is fairly cheap. GPT-4o, like the cost on it is negligible. It's really like peanuts. Like every single run you do on GitHub Action is also costs money, but we don't think about that. It's cheap enough that we don't care. What GitHub takes for GitHub Actions itself. They charge something for that, I think. Or maybe you have a quota. But like it's cheap enough that we don't care. With Sonnet, it's fairly expensive because Sonnet in general is a much more expensive model. And then we made improvements to the agent to do prompt caching, which is a feature from Anthropic where you can essentially write your prompts to cache, and there are all sorts of benefits, and you get a much cheaper price. And then that drove down the cost by 90%. So it really depends on your scenario and on what you're measuring. But you kind of really have to, like, there really is no alternative to it. I hate to say it, but there really is no, like, if you're building AI agents and rolling them out and you want them to be reliable in the real world, there is almost no alternative to writing quality evals today. And OpenAI does it. They have their whole public evals as well. Anthropic does every single company that is serious about develops any form of serious AI agent does it. And it can be a non-negligible cost. because I mean, you're running a live, you're running a live real scenarios at your agent, and you want to test it on the models that you're deploying to your users, or else you're not really testing what you're deploying. So it can be expensive. This is true. Okay. Any further questions before I go on? I'll wait another 10 seconds, and if no one writes something, I'll take that as a no. And we're coming to the end anyway. Oh yeah, good question. One final question here from Padavala. Hope the LLM used to judge the LLM versus the agent are different. So they don't have to be. This is surprising. They don't have to be. What's important is that they don't see is that there's no poisoning, meaning like you want to judge the answer on a set criteria, and you probably don't want to share like the thinking process that went into the LLM or the data it gathered even, because then if the LLM got confused, then your judge will get confused. It's actually really what is really important is if let's say you're comparing Sonnet to let's say you're comparing Sonnet to GPT-5, right? So Anthropic Sonnet versus GPT-5. What's really important is that you use the same judge. It could be that you choose Sonnet as a judge. It could be that you choose GPT-5 as a judge. It actually doesn't even, from our experience, it doesn't seem to matter that much. We would probably take GPT-5 there. Today, all of our evals are still in GPT-4o, which we plan to upgrade to 4.1 or to GPT-5. It doesn't seem to matter that much which like model. We don't see a lot of variance on that, as long as the model is good enough and smart enough. But it is important though that you're judging. You should judge both of them if you're doing comparison between two models. Make sure that the judge model is fixed and isn't like changing between the different things. It could use bias. It could cause bias in theory. I see there's a follow-up on that. It could cause bias in theory. In practice, we're not seeing like we don't see failures due to that because like we're giving really clear criteria and then we're just saying does this match that criteria. So we haven't had issues in that. And I see there's a question about the GitHub repo, and that's been shared in the chat. Okay. So we are almost done. I want to speak about one more topic that is also on our mind, which is kind of the evolution of CI/CD and AI agents. So we're speaking today, like if you think of this, and this is platform engineering community, right? I've been even before we did AI agents, I was lucky and honored to be part of this community. And this is really about CI/CD, and this is really about not just AI agents, but about platform engineering and how do we build reliable software and how do we empower other teams to build reliable software, right? And like how do we build platforms for this? So one part of this, like what we're speaking about today, really is CI/CD, right? How do you adapt? Actually, we're speaking about CI. We're speaking about continuous integration, right? How do you adapt continuous integration and unit testing and the like for AI agents? Well, there's a follow-up on that, which is how do you now bring these reliably into production? And there are two aspects on this. So aspect one is canaries for AI. So what companies like OpenAI do is they'll sometimes do shadow testing of new models. So like someone comes into ChatGPT and they test other models and they test them on real traffic or they roll it out gradually and they see the users interact with a new model a lot more. Is there an increase in latency or cost and so on? It requires a whole lot of traffic to do that. If you're doing A/B tests, like you have to really be on models, you have to have a ton of traffic going through your AI agent. We have a ton of people using this, but it's on the open source, so they're bringing their own models often, unless they're using our commercial platform. So we don't have a high enough level of traffic to do this in a meaningful manner. The other evolution here of CI/CD, though, is along a very different track, which is what do canaries in continuous deployment actually look like in a world of AI agents? So a traditional canary is like you roll out a new piece of software and then you're tracking some very specific hard metric and then you're making like a binary continue the rollout or stop the rollout and roll it back decision. And what becomes really interesting is the question, can you actually take an AI agent now and can you have an AI agent make canary decisions? So one thing that we've been working on here, it might be a good talk for another platform engineering talk at some point, but one thing that we've been working on is open source canaries that are powered by the AI agent. So the ability to essentially like take an AI agent and then run automated checks with that against your environment. And then like, so you could, for example, take use agents to like analyze traffic or the health of new deployments and detect regressions there. So if anyone's interested in this, it is something in the open source, and there's a pull request here called alpha checks. And that's for kind of moving in this direction of being able to like run these checks that would eventually be canaries, where the AI agent is like looking at something and then giving a pass-fail criteria. So that's a little bit on how we see the space evolving here and kind of what we think is next on this, but not the main topic for today. So with that, I'm going to wrap up. I see there's one more question in the chat. And of course, I'll take any more questions that come in. It's a pleasure being here as always. But that's all for my slides. And I hope this has been useful. And for everyone out there going and building agents, I would really, really strongly encourage you to just get started with like even 1 or 2 evals. You don't need a lot of evals to make a difference. Like today we have, I don't know, 150 evals. You don't need that. You start from like 2 evals and 1 eval even. Start from like 1 eval, just testing an interesting scenario, testing it end to end, testing it in the real world, like not just on with mock data or whatever. And run that 1 eval 10, 100 times. You will learn more from that than going through and like testing this manually and trying out a whole bunch of stuff yourself. You learn a ton as soon as you have the framework in place to run and test these evals. And to take the same question now, test the same question 100 times. Sometimes you start to see, well, sometimes it works, but sometimes it doesn't work. And how do you go about that and make that pass 100% of the time? So I would strongly encourage everyone who is working on AI agents to get started and get started easy, just lightweight with a single eval and run that on your AI agents. Okay, I see there's a question. How would you go about evals for simpler scenarios in Kubernetes, like agents using RAG for a knowledge base? So if I'm going to go back again here to prompt foo. Prompt foo, just to remind you, is an open source eval framework. And let me find here the docs. This is all open source. They have some commercial offering that I'm not familiar with. And they have specific instructions also for testing RAGs. So if you go over here, then I think they have here like various guides. Somewhere in here, I believe they have guides as well on like testing LLM chains or evaluating RAG pipelines. And I found a lot of the prompt foo stuff to be incredibly useful as well when we were first getting started. I'm gonna actually go a little bit into why. I'll wait for any other questions to come in, but maybe this is actually an interesting point to elaborate on why we moved away from evaluations as like YAML as just YAML evaluations as code and what I mean by that. So the way prompt foo works is I'll just show you a quick example on this. And then I'll give an analogy again with like with Terraform and manifests. But the way prompt foo works is you give it some LLM providers in YAML, and then you give it like some test properties, like okay, you want to test that doesn't mention you're an AI or a chat assistant. You want to score it based on like how short the output is, for example. And then you have some specific test cases. So here are questions you're asking. So you're like asking, can you help me find a specific product on your website? Do you have any promotions or discounts currently available? And then with prompt foo, it goes through, it asks all of those questions, it scores each one. It gives you a nice table of output on different models comparing to one another. Prompt foo is fantastic. The place it didn't work for us is we needed to really like run code here, and we needed something that was a little bit more extensible because like when we're running an eval, we're not just feeding in a prompt, we're doing a whole bunch of setup. We're deploying stuff in the cluster, we're connecting it to Datadog, connecting it to Prometheus, to Temple, we're pulling trace data, we're writing dummy trace, like we're writing trace data in advance from the application. So like we had to do a whole lot more stuff that was complex. So we preferred something where we're really doing evals as code more. I know I've showed you YAML manifest, but behind that is like a whole lot of code. And for us, we need something that was a little bit more complex, but prompt foo is a fantastic starting place for anyone who wants to get started with this, and I would highly recommend it. Okay, I see there's another question here. If I'm starting a project with agentic AI coding using PRP, is it a good idea to integrate evals already at the PRP creation stage? I need to ask for clarification on PRP. I probably should know what this is and don't, but so please forgive my ignorance on this. Oh, okay, product requirement prompts. Me. I'm gonna assume Gideon that you mean product requirement prompts. Me. So is it okay? Fantastic. So I don't know. What I mean by that is, it really depends on what you're trying to achieve and on your domain. If you want, you can message me on LinkedIn afterwards, and I'm happy to follow up with you on this one-on-one. Um, but it really depends on what you're trying to do to be able to give advice on this, on if you should do that from stage one or like from the first stage or not. But I will tell you what we do is that Claude Code actually writes a lot of our evals. So like our AI agent is like really good at taking a problem or a Prometheus alert or a Datadog alert and going off and like running that and doing an autonomous investigation. It doesn't have the ability to write code. It's not focused for it. It Claude Code is fantastic at writing code. It's fairly annoying to like test Kubernetes stuff on because like you're constantly pressing Shift Enter. But it doesn't have like the right integrations always. So what we've done is we've it, taken our like Claude MD and we put in there very specific instructions on how you write evals. Like if I go back to here, I go back to homes and I go to here to like Claude MD. We have a whole section on here on evals. It's like running and testing evals, how the agent itself, like how Claude itself can run evals, realism is critical, like we how to prevent cheating. So we have like a whole section in here. And then what we do is we essentially use Cloud Code to write a lot of these evals. We'll like tell Cloud Code, oh, like we saw a failure scenario where the agent got X, Y, and Z wrong. Generate for me a reproducible scenario, like at existing evals, like to figure out the how it works, and then generate all of this. And we use Cloud Code to write a lot of those. And so, to answer your question, I guess, and looping back to that, I guess that it would make if you're viewing this as T to D and it's a case where you would where you would normally do T to D, then yeah, I would suggest doing the evals um, at the earlier stage. Again, I'm a little bit less familiar with um, the the framework, so I don't. It's hard for me to answer on that on the spot, but I'm happy to consult on this later. And then another question here um, from Padavala. Hope these eval frames can be configured to work with any model. They can. So it means just doing an inference call. You can run almost all these frameworks on anything. And not only that, but you can give very precise answers on what is better. Like I can now give you a really precise answer on if a customer is going to use a Hugging Face model versus using Sonnet via Bedrock, then what is the implication of that on accuracy on your type of scenarios? So you can give a really precise answer then based on the evals, assuming you have eval coverage, you can give a really precise answer about the trade-offs between using different models. Like we chose to move all of our SaaS customers over to Sonnet. That's in progress now. And we chose to do that because in the evals we saw that that was actually much better than GPT-5. But that's again on our use cases. That is true for us. It's not saying a general statement about the model. Okay, any further questions?
Amazing. We still have, if Natan is willing to give it to us, a little bit of time. If anyone does want to ask something, feel free. But as always, if you do come up with something later upon watching the recording, I'm sure Natan would be very happy if you reached out to him in Slack or on LinkedIn.
I forgot about the Slack. I'm on the platform engineering Slack. Message me there.
Awesome. Well, I think if there's nothing more, thank you, thank you, thank you very much, Natan. This was awesome. I was taking furious notes basically throughout the entire thing, and I'm looking forward to watching the recording. This was super cool. We will definitely have you back again, and don't worry, everyone who's here, we'll let you know next time, so you can tune in for that one too. Always bangers from you. So thank you so much. Thank you everybody for joining. If you're looking for more stuff like this, you can find quite a few blogs on AI. And in the next few weeks, we'll be putting out our State of AI Platform Engineering, where we kind of reviewed and surveyed the platform engineering community and how they're doing. I can give you a sneak preview. They're not doing as well as Natan is doing across the board. So lots to learn from him. So thank you so much, everyone, for joining, and have a great day, morning, evening, wherever